For every 100,000 people, 463 new cancer cases were reported, and 149 people died of cancers, according to the CDC data. The best way to reduce the number of deaths is to early detect the cancers. With it, we can treat them early. There are some traditional techniques to early detect the cancers, such as MRI, MRA, CT scans, PET scans, and X-rays. The main limitations of these methods are use of high-frequency radiation that is harmful to your body. And these are high-cost methods and time-consuming methods. Fluorescence imaging and photoacoustic imaging are two techniques that don't use high-frequency radiation. These are low-cost methods and less time-consuming methods. For fluorescence imaging and photoacoustic imaging, we need materials called organic dyes. Near-infrared region of the electromagnetic spectrum is interested over other regions due to the deeper penetration of the light through the tissues, as well as ability to take high-resolution images. For that, the organic dye should absorb and emit in the near-infrared region. Do you know there is only one FDA-approved organic dye available for human imaging? So it is very challenging to design and develop new organic dyes that absorb and emit in the near-infrared region. In my research, I design and synthesize new organic dyes for fluorescence imaging and photoacoustic imaging to early detect the cancers. Recently, I have developed two organic dyes for fluorescence imaging and photoacoustic imaging. The first dye we can use for fluorescence imaging. This dye can be probed into a targeted cancer cell to get a high-resolution fluorescence image. The second dye I developed for photoacoustic imaging. This dye also can be targeted into a cancer cell, such as brain cancers, breast cancers, to get high-resolution photoacoustic image. And also, we can use these dyes as chemical sensors to detect high level of glutathione in lung cancer cells, copper ions, nitrous oxide in the body. In the future, I will further develop these dyes to get the FDA approval for human imaging.